Welcome back. In this video, we began to learn the machine learning algorithms. Let's get a quick start.
There are four types of the machine learning: supervised learning and unsupervised learning, and semi-supervised learning, and reinforced learning. Supervised learning means that each sample has the labels, and for example, the weather case, when each day is a sample, like the X how the data set, it's the samples and features. Maybe it's the day 1, day 2, the data is our date, and this our features, and also the last columns means that it have its label. A label means that it's raining or not. Zero rain is yes, it's rain, and we use the number 1 to represent, and if it's not rain, we use the 0 to represent, and so on. Is it raining or not? It has the clear labels and clear to describe the day is it raining or not. That's the supervised learning test. And unsupervised learning is the no raining or not, just to find the group of the similar data from their themes, the factors and user factors, and can split the samples as several groups. That is the unsupervised learning. And similar supervised learning, just some samples, maybe these samples have the levels, and these samples doesn't have the levels. It's the semi-supervised learning. First we should use these samples with the labels to predict these samples, and predict the levels, what's the level they are at, and predict them, and then we use the whole data to do the supervised learning. That's the core ideas of semi-supervised learning. And reinforced learning, it can contact the environment. The difference between reinforced learning and supervised learning is the teacher signal. And the reinforced signals provided by environment in reinforced learning is assessment on the actions, rather than telling the learning systems how to perform its correct actions. We give we can see that we give the computer a bunch of the choice questions, and this choice of questions about the training samples, but we don't provide standard answers. It tried to solve these questions, and we judge whether the answer are correct or not. And so if the computers generate more correct answers, we offered more rewards. The computer adjusts its model parameters to make its prediction correct and obey more rewards. Reinforced learning can understood like that as the supervised learning and unsupervised learning. Now we start to learn the regressing first. The sample model is linear regressions, and we can use it to predict the trend of the data. For example, we can use it to predict model temperature. Linear regression is a statistical analysis method. We can use this formula, and maybe the y is equal to, and this the w x, and that's the bias, that's the weight. So the wx, maybe this is the vector, is also the vector, and they can use this formulas and to predict, to have these lines to fit our data, and to we will produce the line to fit the data, and then to predict the trend of the weather, the trend of the price of the house. So that's the linear regressing core ideas. Just use the functions, the formulas. So how we can use the linear regressions to do classification? Let's see logistic regressions. We can use the sigma values to convert the values into the 0 and 1 this space. And we can give a threshold value. If we use the 0.5 as a threshold value, for example, if we judge the D is the hot or not, the first we should use the formulas to transfer our values into the 1, 0, or 1, this area. If the value is larger 0.5, it will be the hot day, maybe the hot day. And if the value is smaller than 0.5, will be not hot. Maybe not hot. That's the result. That's the logistic regression used regressing ideas to do classification. Let's see another algorithms, a decision tree. A tree likes a scratch like that. It has nodes and branch and leaf, and there is a branch, and each non-leaf nodes represent a test on the feature attribute, and each branch represents the output of the feature attributes at the certain value range, and each leaf node stores the class. And to use the decision tree, start from the root node and test the feature attributes of items to do classification, and select the output branches and use the class storage on the left as the final result. That's the final result. About that, to do this. This is ideas to do classification. For example, a girl is considered whether to date with the guys or not. If the girl thinks the age is smaller than 30, I will to consider his look. If there is a larger one than 30, I will reject his date. So, like the preference the human seeking, this is the different branches are constructed based on the different factors attributes nodes. And the decision tree learning algorithms is used to generate the decision trees like that. When there are more and more features, logistic and decision tree will perform not well. And SVMs can hold it. SVMs support vector and machine. And its basic models is the linear classification and defined in the feature space with the largest internal. And the internal is in the line is also the support vectors, and the support vectors that can make the data split into two parts. And when we solve the large more features, larger data, SVMs can solve you with the kernel functions and make it a nonlinear classification, such as the right pictures, and it can match the features into the high dimensional use the kernel functions. So the SVMs also can solve the large data problems. Let's see how we use the probability to do classifications. And naive Bayes is based on these core ideas. They use the probability to do the classification. And we can see from the formulas, and X is the data samples, and which generally is described with the measurement value of n attribute sets, and it is a hypothesis. For example, the data X belongs to the 113 state. PHX is the posterior probability, or its posterior probability under the condition X, and PH is the prior probability, or its prior probability, and is the independent of the X. And Px is the prior probability of the X. Thus, we can calculate probabilities that the sample belong to the class X. For example, in the weather case, we can get the tomorrow is the 14%, the weather is the temperature is above the 25, And if the weather is above the 25, and there will be 8% will be sunny. So there will be, we can calculate it. There tomorrow there will be 13.2% it will be sunny. So the total probability is to get all conditional probabilities, and the total result will be the final result. And that's the core ideas of naive Bayes. Let's see how we use the distance to solve the classification. The KAN, the K nearest neighbors, and the classification algorithms. K nearest neighbors also is the core ideas of the KAN. If the majority of the key samples that are the most similar to the one sample belong to the one sample, the sample also belong to these samples. Let's look at the picture and let's see the process of the KAN algorithms. This is about our training data, and this is about the test data. If they have the new code, and we will calculate the distance between the other nodes, and then we will rank the distance like that, and we'll find the k top k, the distance. If we find that there are two nodes are the blues, the green nodes will belong to the blue group class. That's the core ideas of the user distance to do classification.
Now we have introduced about some core ideas of these common algorithms. Now we have the many engineers also used these algorithms to do data mining works. It is also very important nowadays. In next video, we will learn how to make these algorithms perform better. See you in next video. Bye.